This is the next project. It's a sapele hardwood door and frame. I'll try and put some photos up here of the existing one, which is made from pine and it's all rotten away. But the door itself is quite a simple design. You got a couple of little side panels here. All the top is glazing, but it's quite a decorative glass, so that's what's adding the feature to it. It's all stained glass and leaded. The frame itself is quite deep. Standard frame, or it is in the UK, is around 70mm, 80mm. Same thickness is 70mm on the actual width, but the depth of the frame on this one's about 6 inch. So I can't do all my tenons on my tenon like I normally would, because I have on my tenon, I have on this profile, there's an half round beading or an ovlow beading, which is all preformed into the frame itself. It's not separate beading. I'd normally do that on my tenon and spindle molder all in one. So I'll cut the mold in, the rebate, and the tenon would do my tenon and the end profile. But I can only go to around 90mm on the tenon that I've got, and with this being 6 inch it won't fit. So I'm gonna have to do this a little bit differently. I'm gonna have to machine all the separate parts and then hand cut the tenons. Most likely I'll use a domino for the tenons and just do a loose tenon on that one and screw it together. This is all the timber for the doors and the side panel, among for another job as well. So it's a standard exterior door thickness, which is 44mm in the UK. But my first step is to get all these cut down to size, get them squared, planed up, machined, and get the frame out of the way so I can get all the dimensions and sizes that I need for my side panels and my door. And then I need to get the glass ordered. This is essentially what I need to create for the door frame. So we've got 2 ovlow beadings either side with the rebated section for the door and the side panel to go in. As I mentioned, I do have a cutter that will cut everything all in one. So I'll cut this rounded ovlow molding as well as the rebate and the drip channel. But this is only going to take me up to 90mm and these are 110, so it won't actually fit on my cutter block. I could run it on this block, which will leave me with a section to machine off and then run down with a rebate, but that's going to create this section a different size to what it needs to be. It's going to leave me up to almost a 60mm thickness door, and I'm matching up to the existing style of door, which is only 44mm. So the way I'm going to get around this is I'm going to use a standard ovlow cutter blade to cut both my roundovers, and then I'll just run these off with a rebate block. This is fine for doing all the profiles, but it's going to make it a little bit more difficult for my tenons, which is why I'm going to do a loose tenon with a domino. I'll just do a stub tenon on here, chamfer both corners off on the miter saw, and then when I get onto the frame sections, I'll just pair them off with a hammer and chisel to get them to meet, and then I'll insert my loose tenons. But I'm going to get set up on the spindle molder to set up for these curved profiles and the rebates to get all the mouldings put on everything ready for them marking out for assembling. So one thing that you're always going to get with sapele is just because of the grain, it does chip quite easily on the edges when you're machining out, as you can see here. One way of getting around it is to do a very shallow pass to start with and then starting taking deeper passes to get your profiles. I haven't done it with this one because it's only a small profile. So the way I'm going to get round it is I've made these timbers thicker than what they need to be. My finished dimension for this is 70mm wide. These are actually 72mm in width. So I'm now going to go back onto the thickness plane and take 1mm off each side, which will clean all this edge up and give me a nice clean finish on that profile to then run the rebate for the door and the side panels. And this is just a quicker way of doing it rather than doing a shallow pass. It's only a small beading, so I can quite comfortably do it all in one go, and I've also got the thickness on the timber to be able to plane it down afterwards. So that's all my profile now done on the frame. I've got both of my rebates on. These are going to be dividing, so these are going to be transoms where I've got the glazing and the side panel underneath. Also got both of the Ovlo roundovers. Because of the thickness of the frame, I can't put it on my tenon to do these. So I'm going to do a stub tenon where it meets in and then use the domino to do two loose tenons, top and bottom, and put a screw through the middle. In order to create the profiles where they meet, you could do this where you're going to the corners with a router, but then you're going to have a round over, which I don't want. So what I'm going to do is I'm going to jump on the miter saw, and on both corners I'm going to take a 45-degree cut off, just where my Ovlo beading starts, and then where it's meeting on my other timbers, so on my sides and my top rail, I'll run a trench down on the miter saw as well, and then the 45 degrees either side, I'll just use a 45-degree block and then cut that down, pare it down with my hammer and chisel to create that. It'll take a little bit longer to do this way, but it's probably the easiest way to do it without having to go and buy molder cutters to do a one-off frame at 110mm. I do have these cutters for standard ones, which are anywhere between 70 and 90mm, which allows me to do 44mm doors up to 52mm doors, but this one's just slightly over, and there's no point in going to the expense of buying the cutters for these, which will be close to £300 just for one door, and the customer won't really want to pay that, and I wouldn't want to charge them that just for a set of cutters that I'd never use again, because it's very rare or very unlikely that I'll get another set of doors with a frame at 110mm with the same profiling and detailing that this has got. So I'm going to jump on the miter saw and get these cut off. Frame will then be ready for putting the loose tenons on and getting it assembled, ready for doing the doors. So that's what I'm left with, both sides, 245 degrees, and this is going to flush fit up to where the rebate is. I'll then put a couple of loose tenons in there, and there'll be one screw in the middle just holding it together while the glue sets. But that's all pretty much set up now, ready to trench cut the other section out on the head and the styles. So I'm going to cut these out by hand. I'll score down with a saw and then take this out with a hammer and chisel. Move all this now with a hammer and chisel, both coming from both sides so I don't cause any damage. And then flatten it off. So I've just made up a simple jig. This is just a piece of scrap piece of timber that's a nose square and straight, and I've done a 45-degree cut on it. I have also already marked where the outside edges of my 45 degrees need to start. So I'm just going to rest my chisel along this as a guide and slowly work down on both sides, and that should give me both my 45 degrees that I need. Once that's all clamped up, I should get a really nice tight joint on there. That's loosely placed in, so I'll get a couple of loose tenons in there and a screw which will pull this joint up nice and tight. And I just need to repeat the rest for all the other ones, and also down the styles of the frame. And I've got my 2 cross members. So the glass has arrived. It's taken around 3 days from ordering to being delivered. It's a 6mm toughened glass. These won't be glued into place because they are quite a snug fit. I don't have to worry about putting some silicone in to stop them from vibrating or rattling when the door's opened and closed. And having the central glazing bars and everything glued into place just makes it easier for fitting everything. If I was trying to fit the glass and gluing everything all up at once, these middle rails will probably shift around and come misaligned. But having my entire central section fully glued up and hardened, I can quite easily get my panels in, give them a tap into place, and then get my 2 styles in. I'm going to get my straps on now to make sure my top and bottom rails in place and secured, and then I start lining these up, getting a clamp on the middle to pull my styles in, and there'll be 2 more bandings going on. I'm going to start and assemble the frame. I've got my loose tens already and the glue that I'm using. It's a Titebond 3 because it's an exterior frame. So I've paired off both my sides and I'm ready for gluing up. I'm going to be putting a screw in to hold everything together because this is a large frame. Plenty of glue on the actual joint itself. So with this frame, I need to make sure if it's glued up in sections, just because it's too large to get glued up in one. So I'm going to do one side, get my middle transom on, get that screwed and fixed up. And then on this side, I'm going to drill a pilot hole. I'm going to pull a screw into it to get it nice and tight. That's the frame done, and it is a big old frame, over 8 foot in height, nearly 6 foot wide. Do have a couple of side panels in the bottom to do. All the top ones here are all glazed. So there's really just 2 lower side panels. These are going to be solid to match in with the door. Got my timber cut down to size, ready for squaring and planing off. These are all the joints. So I've noticed that my stiles are thinner than my inner rails. This is because on this type of property, it's almost like a sash window kind of installment where the exterior wall extends over the frame and then the frame goes in behind the exterior wall. Normally that's not a problem because you'd fit the frame from inside and have some architrave round both sides and the top. Because the customer's already finished their interior of the work, so they've got skirting boards and I believe they've got a picture rail, we can't actually fit it from the inside. So I've chosen to do the thinner stiles here. These are about 50mm, these are 70. So when the old frame comes out, there'll be a small bit of timber which will go screw onto the interior brickwork, which will bring it level here with the stonework, and then this will flush in. And once it's all sealed up with mastic, this joint between the 2 timbers will be invisible, you'll not see it. And that's really the only way to get this in without them having to chip away all the interior plasterwork and take the skirtings and picture rails, and I believe they've also got a dado rail which have just been done. So to avoid them from damaging all the interior hallway, it's going to be fitted from the outside in. So I'm going to get onto the door next. It's quite a large door, it's over 1 metre wide, 7 foot in height. So I've got everything machined up and planed down. I'm ready to put the groove in. These are just flat panels, and on this door they're going to be 25mm thickness. The bottom rail is acting differently to a normal one. Normally I'd only go down around 15-20mm for my groove down there, but on this rail I've got a chamfer detail on both sides. Comes down around 60mm, so both corners or both edges are going to be chamfered. All this is going to be removed. So I'm going to be left with a really thin detail at the top. This is only going to be around 6mm because I'm matching up to the existing door. So this groove I'm going to take down the same thickness or the same depth as my groove. So I'm going to take it down around 50-55mm. I'm going to insert my panel fully down, glue it on the bottom edge. Normally a panel on an external door won't be glued in. You need to allow for movement. Any movement that's going to happen with a panel, it's going to be on the width and not the length. So in order to stop any of this timber here from bowing out or splaying, my panel is going to effectively act as a stub tenon, and the panel will go into the stile as well. So that'll hold this bottom edge firm without any movement. Because it's so deep and it's 25mm, I'm going to use a split groover on my spindle motor. So this is basically just a core block that's in 2 halves, and you can adjust the thickness depending on what shims you put in. We've got multiple different shims, different thicknesses from 3mm down to, I believe the thinnest is 0.25mm. So I already know I need 3 of my shims in for a 25mm groove. So that'll be stacked up, and because you've got core blocks top and bottom as well as a scribing knife on both pieces, that's going to give you a nice clean groove without any having to use a wobble board, which is basically a blade that kicks up and down as it rotates in the spindle molder. These are fine for doing multiple different grooves because they're fine adjustable, but because the blade's going up and down, they can tear out on the top edge, which leaves you a rough surface, so then you've got to plane down afterwards. This eliminates that kind of fault. So I'll run a shallow pass to start with, a couple of mil deep, just to prevent any tear out. Most of the scribing blades on the top and bottom prevent this anyway, but just to make sure, I'll do a very shallow pass, and then I'll take my final thicknesses down in 2 to 3 passes. And once I've done these, I'll be able to chamfer the 2 edges and also get onto my tenoner to do the tenons as well as my mortisers on the mortiser. There's no scribing on this, so it's a very simple door, so they're all square edges, so I don't have to install the scribing blade on my tenoner. I can just put 2 rebating blocks to give me a square tenon. A spindle molder is a fantastic bit of kit. It's essentially just a giant router table, but way more versatile. It allows you to put larger blocks on, so you can do larger pieces of work, so you can do large covings and mouldings. It's also a lot more powerful because you can fit a power feed onto it, which is basically an automatic machine that feeds the timber through for you, so you don't have to put your fingers anywhere near it. I'm going to get my split grooving blade all fitted on with the shims that I need. This is going to give me a 25mm rebate for my panels. So I want to set my rebate from the top scribing blade, not the cutter blade here. This is the highest point on this type of cutter block, is the scribing knife. So I'm going to set this at 31mm above the bed. This is then going to give me 25mm. Because I'm having to do this manually, what I'm going to do is I'm going to rotate my timber. So I'm going to put each piece of timber through twice to ensure that my groove's dead bang in the middle of the timber. I want to do a very shallow pass to start with. So this is only going to be a couple of mil deep at the most, 1 to 2mm. And because this is a spindle molder, ideally you don't want your fingers anywhere near the blade. This machine isn't something that's just going to give you a little cut or a nick on your finger. It's basically going to take a finger off. And more than likely it's going to pull your hand into the blade itself, creating more damage. So wherever possible, you want to be using a power feed. Not only will it give you a more consistent and smooth cut, it's going to fully enclose the blade, so you've got no risk of ever getting your fingers anywhere near it, which just makes it a lot more safer to use. Spindle molders are probably the most dangerous machines that you can get over any other in the workshop, just because of the amount of damage it can do. You're not just going to get a little nick or a cut on end of your finger if you get your hand anywhere near the blade. You're going to most certainly take the end of your finger off, if not more. And what's most common is, because the blade's rotating and you get your hand near it, it's going to pull your hand into it, in between the fence and the blade, and you'll lose multiple fingers and possibly a hand. So a power feed, in my opinion, is essential bit of kit for any spindle molding work. Not only does it keep your hands and fingers safe because you've just got no access to it anywhere. Worst thing that's going to happen is your timber's going to kick and everything's going to move, but it's more easy to replace a bit of machinery than your fingers. But it's also going to give you a more consistent feed because it's constantly pushing it through. You're not stopping and starting. As you're doing it by hand, you're always going to be taking hands off to feed your timber through, especially with long timbers. So you're going to be essentially stopping and starting, or slowing down, potentially lifting the pressure off, which is going to make your board potentially rock and move. Your power feeder, it eliminates all that. It's a constant pressure down to the bed, also into the fens, as well as pushing it through in one smooth motion. So it's definitely a piece of kit that you should be investing in if you're doing any type of spindle molding where you're doing lots of repeat cuts and moldings and things like that. So I've got all the grooves cut in all my timbers. I've also chamfered the bottom edge of my bottom rail on both sides. Where it meets my style, it's not an issue because this is the design of the door. It's a square style with the chamfered detail here. But this is going to be my middle rail, which is going to fit in the middle where it steps down. This is going to cause me a problem with jointing it. So what I actually need to do on my bottom rail is trench out a section the same width as my middle rail, coming down where the chamfer stops, which is around here somewhere. And then this will fit in with a mortise and tenon, which will go into my bottom rail. I've actually decided against going down the full thickness of the groove on the bottom rail by 60mm, because I believe it's going to leave these pieces of timber just too vulnerable, even though I've got my panel in. It's still potentially reducing this by 60mm. It's going to make this section of timber, especially on the exterior side, prone to warping. So I've just done my standard depth of groove, which is around, in this case, I think it's around 16-17mm. So on this, I'll just do a double tenon with a double haunch as well. So essentially a haunch is a stub tenon, really, to put it simply. So this piece of timber, once I cut my tenon in, I'll have two tenons sticking into the timber here, with a haunch on the top and a haunch on the bottom, as well as in the middle. That ties that full section into my stiles. And then I'll have my two tenons here. I'll either just do a standard tenon, or I'll do a foxtail tenon on these to wedge it in. But usually with the glue that I use, because I'm using a resin glue, I'll just do a standard double tenon, because I'm not really concerned about any joints pulling apart